Welcome to the Deep Dive. We're the show where we take a whole stack of sources and, well, pull out the really key stuff, the knowledge, and the surprising bits you might miss.
Yeah, distill it down.
Exactly. And today, our mission, our deep dive, is into the life and, wow, the mind of Stephen William Hawking. I mean, one of the most brilliant theoretical physicists, cosmologists ever, really.
Absolutely.
And we want to go beyond just the famous image. We want to explore his huge scientific work, of course, but also the other things, the lesser-known stuff that made him so, well, unique.
And you know what's really striking, almost poetic? He was born exactly 300 years after Galileo died.
Wow.
And he died on the exact anniversary of Albert Einstein's birth. It's like the universe itself was setting up these connections, wasn't it?
That's incredible. It really suggests something about, I don't know, the flow of scientific history. So, okay, everyone, buckle up. We're heading into cosmology, quantum mechanics, this amazing story of perseverance, and, yeah, some facts that might really surprise you.
Let's get into it.
Okay, so first, let's just set the scene for his genius, his main areas. Theoretical physics, cosmology, general relativity, quantum gravity, big stuff.
The really big questions, yeah.
These were the fields where he made these breakthroughs that, well, cemented his legacy. And maybe the most famous one, definitely radical, was about black holes. It totally changed how we saw them.
That would be Hawking radiation. He put that forward in 1974. And the core idea was just revolutionary. Black holes aren't completely black. They're not these eternal prisons we thought they were.
Right.
They actually leak. They emit radiation. It happens because of quantum effects right near the edge, the event horizon. Basically, pairs of particles pop into existence.
Virtual particles.
Exactly. Yeah. One falls in, the other escapes, and that escaping particle carries energy away. So the black hole loses mass.
So wait, if they're losing energy, losing mass, does that mean they can eventually just disappear? Evaporate?
The implication, yeah. It completely flipped the script. It meant black holes have a lifespan, a really, really long one, but still finite.
Wow. So what does that mean for, the universe's ultimate fate? These things aren't permanent.
It suggested that nothing, not even these cosmic vacuum cleaners, escapes the fundamental laws, particularly quantum mechanics. They aren't eternal prisons. They decay. Which immediately raised another massive question.
Which was?
If stuff falls in and the black hole evaporates, what happens to the information about what fell in? Does it just vanish? That became the famous information paradox. He wrestled with that for ages.
Okay, we'll definitely circle back to that paradox. But before that, there were his singularity theorems, right? Working with Roger Penrose.
Yes, absolutely fundamental work. They used mathematics, general relativity's math, to prove that singularities, these points where density becomes infinite, aren't just weird possibilities. They're inevitable.
Inevitable under general relativity.
Correct. If general relativity holds in those extreme conditions, then singularities must form inside black holes. And crucially, the Big Bang itself likely started from one.
So it gives a kind of mathematical certainty to these really extreme ideas, both the start of the universe and the nature of black holes.
Exactly. It showed these weren't just fringe ideas. They were direct consequences of Einstein's theory. It gave a solid foundation to cosmology and black hole physics.
And then, shifting slightly, there was the no-boundary proposal. He developed that with James Hartle.
Another mind-bending one. The idea here is that the universe, while being finite in size and age, doesn't actually have a boundary or an edge, or even a distinct starting point in time in the way we usually think of it.
Finite, but no boundary. How do we picture that? Is there an analogy?
The classic analogy is the surface of the Earth, or any sphere. Its surface area is finite, right? You can measure it.
Sure.
But if you walk on it, you never fall off an edge. You never hit a boundary. You can just keep going.
Oh, okay. I see.
So the idea is the universe, in terms of space-time, might be like that. Finite, but self-contained. No starting singularity point you can point to as the beginning. It sort of smoothly comes into being.
That really messes with your intuition about beginnings and ends.
It does. That's cosmology for you.
And related to all this, he was a real pioneer in quantum cosmology, trying to bring quantum mechanics and general relativity together, especially for the very, very early universe.
Yeah, that's the ultimate challenge in physics, isn't it? Trying to unify those two.
Right.
Because they describe reality so differently.
How so? Why is it such a huge challenge?
Well, you've got general relativity, which describes gravity and large-scale structures. planets, galaxies, as this smooth, continuous fabric of space-time. Think curves in geometry.
Okay.
Then you've got quantum mechanics, describing the very small atoms, particles, which is all about probabilities, discrete packets of energy, weird quantum jumps. It's lumpy and probabilistic.
So smooth versus lumpy, deterministic versus probabilistic.
Basically, yeah. Trying to make those two descriptions work together, especially in extreme places like the Big Bang or inside black holes where you need both gravity and quantum effects, it's incredibly difficult. The math just doesn't mesh easily. That's the monumental task.
And yet, despite tackling these incredibly complex, abstract ideas, he managed to connect with millions of ordinary people through his writing.
Oh, absolutely. His popular science writing was extraordinary. He had this gift, this unique ability to make it all accessible, captivating even.
A Brief History of Time, 1988. That book was just phenomenal. Sold, over 25 million copies.
Yeah, an unbelievable number for a book about cosmology. He didn't just explain it. He made people want to understand it. He made it digestible.
And he didn't stop there. There was The Universe in a Nutshell, The Grand Design, Black Holes and Baby Universes, and that posthumous one, Brief Answers to the Big Questions.
It really makes you think, doesn't it, how important it is for scientists, especially those working at the absolute cutting edge, to communicate what they're doing.
Why is that so crucial, do you think?
Well, several reasons. It educates the public, obviously. It fosters scientific literacy, but it also shows people why this fundamental research matters, even if it seems abstract. And crucially, it inspires the next generation. Think how many kids read A Brief History of Time and thought, wow, I want to study physics. Hawking was a master at building that bridge.
Yeah, absolutely. Okay, let's shift gears a bit now to the human story, because it's just as remarkable as the science.
It really is.
He was diagnosed with ALS, amyotrophic lateral sclerosis, Lou Gehrig's disease, when he was just 21.
Mm-hmm. A devastating diagnosis.
Doctors gave him, 2 or 3 years to live?
That was the prognosis, yes. Just a couple of years.
And yet, he lived for over 50 years after that. 5 decades. It's just astonishing.
Truly astonishing. The disease progressed, of course. He lost control of almost all his muscles over time. But, and this is the critical part, his mind, his cognitive abilities remained completely sharp, untouched.
And the way he continued to work, to communicate, eventually using that speech-generating device, operated by just tiny movements in his cheek.
Yes. A sensor picked up twitches in his cheek muscle, which allowed him to select words, build sentences. It required incredible patience, incredible adaptation. It's hard to even fathom the level of determination involved.
It really is staggering. Just the sheer willpower to face that kind of relentless physical deterioration, but keep your mind focused on the biggest questions in the universe. What do you think drove that? What kept him going?
I think it must have been an absolutely insatiable curiosity, a deep, deep need to understand. The universe was his playground, his laboratory, and his mind was free to roam there, even if his body wasn't. The intellectual pursuit was perhaps a kind of ultimate freedom for him.
A freedom that transcended the physical limitations.
Precisely. And speaking of his path, academically, it started quite young. He went to Oxford for physics at 17, then Cambridge for his PhD in cosmology.
And later held that incredibly prestigious position, Lucasian Professor of Mathematics at Cambridge.
The same chair Isaac Newton held.
Exactly. Isaac Newton. The historical significance of that.
Yeah.
It's huge. 2 figures, centuries apart, holding the same position and fundamentally changing how we see the universe.
Yeah.
What does that signify, really?
Well, the Lucasian chair isn't just any professorship. It represents the pinnacle of mathematical and scientific thinking at Cambridge. For Hawking to hold the same chair as Newton. Newton, who laid down the laws of gravity and motion for the everyday world, while Hawking was exploring gravity's extremes and its connection to quantum reality, it really places him in that direct lineage, one of the true giants.
Yeah, and his influence went way beyond academia, didn't it?
Right.
Which is so unusual for a theoretical physicist. He became this global icon.
Incredibly rare. He popped up in popular culture everywhere. The Simpsons, Star Trek, The Next Generation, The Big Bang Theory.
Right, and then the movie The Theory of Everything, back in 2014. Eddie Redmayne won an Oscar for playing him. That brought his story, both personal and scientific, to an even wider audience.
It did. He became more than just a scientist. He became a symbol, really. A symbol of what the human mind can achieve, of perseverance against unbelievable odds, intellect triumphing over physical adversity.
It is just so rare for someone working on, let's face it, incredibly abstract stuff to become that kind of household name, that kind of cultural figure.
It is. I think the combination of the profound ideas and the compelling human story just resonated deeply with people all over the world.
Okay, now for a part, I always find fascinating these deep dives, the lesser-known stuff, the surprising sides of Stephen Hawking. This is where you see the person behind the icon.
Yeah, the human
Like,
details.
did you know he apparently refused a knighthood?
I had heard that, yeah. Reportedly, it was a protest, wasn't it? Over the UK government's approach to science funding at the time.
Right. Which says something, doesn't it? He wasn't just about the science. He was willing to take a stand on principle, even turning down a major honor.
It shows a strong conviction, a willingness to use his considerable platform. It wasn't just personal, it was a statement about the value of science itself.
And here's another one. Apparently, he wasn't a stellar student early on. Like, his grades were pretty average until his later teens.
Yeah, that's often mentioned. Not a child prodigy in the traditional sense. He seemed to find his real focus later. It's kind of reassuring in a way, isn't it?
It is. You don't have to be brilliant from day one. But okay, my favorite surprising fact. He loved pranks. He had a real sense of humor. Apparently used to play jokes on colleagues.
That's brilliant. It just makes him seem so much more real. You imagine this towering intellect, but he also liked a good laugh. Maybe he used that famous voice synthesizer for some witty comebacks or practical jokes.
Totally. Imagine getting zinged by Stephen Hawking's computer voice during a serious physics debate.
It probably helped, dealing with the intensity of the work, the condition. Humor is a powerful tool.
He also liked making bets on scientific outcomes. Famously bet against the discovery of the Higgs boson and lost, and bet on the information paradox.
And changed his mind on that one later. We'll get to that. But yeah, he engaged with the scientific process in a very human, sometimes competitive way.
And then, despite everything, in 2007 he took a zero-gravity flight, experienced weightlessness.
Incredible. That sheer adventurous spirit, wanting to experience things, pushing boundaries, not just intellectually, but physically, as much as he could. That's amazing.
Yeah. And one last small detail.
Yeah.
That voice synthesizer. He kept the original American accent, even when newer, perhaps more advanced versions came along. Why? Because he'd grown attached to it. He identified with it.
It became his voice, didn't it? That specific synthesized sound. It shows how personality and identity adapt and integrate even with technology, especially when it's so central to your way of interacting with the world.
These little details really paint a richer picture, don't they?
They absolutely do. They show the whole person.
Okay, let's move towards some of his more, let's say, speculative ideas, the really big, thought-provoking stuff. He was a believer in the multiverse, for instance, the idea that our universe isn't the only one.
Right. The idea that there could be countless other universes, maybe with different laws of physics, different histories, bubbling off from each other, perhaps.
What does entertaining that possibility even do to our understanding of? Well, everything. Our place in the cosmos.
It's profound. It potentially demotes our universe from being the universe to just a universe, one sample in a vast cosmic landscape. It could, maybe, explain why our universe seems so finely tuned for life if there are infinite universes. Maybe some are bound to be habitable by chance. It radically shifts perspective.
And he also had some pretty serious warnings, didn't he? About AI, artificial intelligence, and also about contacting potential alien civilizations.
He did. He voiced concerns that AI, if it developed beyond a certain point, could surpass human intelligence and potentially pose an existential threat. Not necessarily out of malice, but perhaps out of goals misaligned with ours.
A sort of superintelligence we couldn't control.
Possibly. And with aliens, his warning was cautious. He likened a potential encounter to Columbus arriving in the Americas, suggesting that for the native civilization, us, it might not turn out so well if the other civilization is vastly more advanced.
So caution was the key word there. Don't just blindly reach out.
His perspective came from thinking on cosmic timescales and understanding power dynamics, both human and potentially extraterrestrial. It prompts us to think very carefully about our future trajectory and our place, should we find we're not alone.
And let's circle back now, as promised, to that black hole information paradox. That clash between general relativity and quantum mechanics. You mentioned he wrestled with it for decades.
Yes, it was a deep contradiction. Quantum mechanics insists that information about a particle's state can't fundamentally be destroyed. It has to go somewhere.
Right. Information conservation.
But classic general relativity and Hawking's own earlier work on black holes suggested that once something crosses the event horizon, it's cut off. Its information is lost to the outside universe forever. And if the black hole then evaporates via Hawking radiation, where did the information go? It seemed to just vanish.
A direct conflict between the two pillars of modern physics.
Exactly, a major theoretical crisis.
And the truly remarkable thing, especially given how central Hawking radiation was to his work, was that in 2004, he publicly announced he'd changed his mind. He said information isn't lost.
Yes. That was a huge moment in theoretical physics. After arguing for decades that information was destroyed, he came around to the view that somehow, subtly, information does get out. Maybe encoded in the outgoing Hawking radiation itself, though the exact mechanism is still heavily debated.
Intellectual honesty, the courage to publicly reverse your position on something so fundamental, especially when you're Stephen Hawking, that's quite something.
It's a testament to the scientific spirit, isn't it? It's not about being right all the time. It's about following the evidence and the logic, even if it leads you to overturn your own long-held beliefs. It showed incredible intellectual integrity.
Absolutely. So as we kind of wrap up this deep dive, let's consider his legacy. He won so many awards, didn't he?
Oh, a huge number. The Copley Medal from the Royal Society, the Presidential Medal of Freedom from the U.S., the Wolf Prize in Physics, Companion of Honor in the U.K. Major accolades.
But there's the elephant in the room, as they say. He never won the Nobel Prize.
That's true. And the main reason generally cited is that the Nobel Prize in Physics typically requires direct experimental or observational confirmation of a theory.
And Hawking radiation, while widely accepted theoretically, hasn't been directly observed. The radiation from stellar mass black holes would be incredibly faint, swamped by background noise.
Exactly. So while his theoretical contributions were monumental, they lacked that specific kind of empirical proof during his lifetime. But, does it diminish his legacy? I don't think so.
No, not at all. His impact on cosmology, on theoretical physics, on just our fundamental understanding of gravity and quantum mechanics, it's undeniable. It transcends any single award.
Absolutely. His ideas reshaped entire fields of research.
He passed away on March 14th, 2018, age 76. That date again. Einstein's birthday.
And his burial location is also incredibly significant. His ashes were interred in Westminster Abbey in London.
Right between Isaac Newton and Charles Darwin.
Yes. Placed among arguably the two most influential British scientists in history. Newton, who defined classical physics and gravity, and Darwin, who defined modern biology.
The symbolism there is just immense. It speaks volumes about how his contributions are viewed in the grand sweep of scientific history.
It really does. It acknowledges his place in that pantheon.
Yeah.
So his enduring impact, it's really threefold, isn't it?
How would you summarize that?
Well, first, obviously, the groundbreaking science, pushing the boundaries of cosmology and quantum gravity. Second, his ability to communicate that science through his books, making the universe accessible to millions. Third, the personal story. The sheer inspiration of his life, overcoming immense physical adversity to live such a full, intellectually vibrant life. It's a powerful message about human potential.
He put it so well himself in that quote. However difficult life may seem, there is always something you can do and succeed at.
A perfect summary of his philosophy, really. So as we finish, maybe it's worth reflecting on that intersection he embodied, the vast cosmic scale he studied, and the resilience of the individual human spirit he demonstrated.
Yeah. And maybe a final thought for you, the listener, to ponder. Given Hawking's insights about the cosmos, AI, maybe even the multiverse, and seeing his own incredible life story, what does that tell us about our responsibility? Our responsibility as a species to keep exploring, to understand this universe, but also to prepare wisely for the future, knowing that things that seem impossible today, well, maybe they're just waiting for a shift in perspective.
Bye.